talking about acceleration. So by the end of this lesson, you'll be able to define what acceleration is mathematically and conceptually. You'll be able to know when an object is undergoing acceleration, make a distinction between velocity and acceleration, and make acceleration versus time graphs from velocity versus time graphs. Big day today. Okay, so first off, acceleration can be defined as the rate at which velocity changes. The rate at which velocity changes. A little bit more like real world description of that is how quickly you are speeding up. Okay, how quickly you're speeding up. Acceleration. Okay. The variable for that is a lowercase a. The equation for that is a change in velocity over time interval. The rate at which velocity is changing. You can expand that to be final velocity minus initial velocity, the change in velocity over final clock reading minus initial clock reading. Good with that. Okay. Now the units. What's the unit for velocity? Meters per second. What's the unit for time? Seconds. So everybody see where I was pulling that from? Acceleration is equal to change in velocity over time interval. Velocity, units of meters per second. Time, units of seconds. Acceleration, the unit for acceleration is meters per second per second. Okay, it's how much you change your velocity every 1 second. Meters per second per second. Now, mathematically, we can simplify that. That's like a complex fraction, compound fraction, complex. I don't know what to. You can simplify that to meters per second squared. Okay, but conceptually, meters per second is a better way to like digest that. Okay, to give you we don't really have a good like ownership of meters per second, but we do have a good ownership of miles per hour. So a way we could relate acceleration with units that we're more familiar with would be saying miles per hour per second. So if you had an acceleration of 5 miles an hour per second, your speedometer would look like this: 0, 5 miles an hour, 10 miles an hour, 15 miles an hour, 20 miles an hour, 25 miles an hour, 30 miles an hour. Every second that goes by, you're changing your velocity by 5 miles an hour. Does that make sense? Do you see what that communicates? Okay. Now, I'm never going to use miles an hour per second. That's just crazy. But it gives us good conceptual understanding of what that is. Okay. Good there? Thumbs up when you have a guess. Have a conversation. Correct answer is A. Good with that. Okay. Cruise control. What happens to your velocity? Stays the same. Acceleration is the rate at which your velocity changes. How much is your velocity changing? Not. So no acceleration. So one thing that's confusing is this idea between what the velocity is and what acceleration is. You can be moving really fast and have no acceleration if your velocity remains constant. Okay. So close. Next. Have a conversation. Correct answer is? Correct answer is actually E, all of them. Okay, so velocity communicates two things. What are those two things? Speed and direction. It's a vector. Okay, so if you change either one of those two things, speed or direction, that constitutes acceleration. Everybody's fine with that. That's how we use it in normal everyday life. But if you slow down, you're also changing your velocity. That constitutes an acceleration. If you also change your direction, that's a part of velocity. If that changes, there is acceleration as well. So that's kind of technically, from a physics standpoint of view, anytime you change any part of velocity, you have acceleration. Okay. Thumbs up when you have a guess. Tell your neighbor. Correct answer is the bike. The bike? It's going so much slower. Why do you say the bike has a greater acceleration? Okay, it's not about how fast it's going, it's about how quickly the velocity is changing. Are we seeing that? Okay. Thumbs up when you have a guess. Talk to your neighbor. All right. Conceptually, well, correct answer is what? C. Conceptually, here's the idea. Every second that goes by, you change your velocity by 2 meters a second. So it goes 0, 2 meters a second, 4 meters a second, 6 meters a second, 8 meters a second, 10 meters a second, 12 meters a second. Over 6 seconds, changing your velocity by 2 meters per second every second, you'll have a total of 12 meters a second at the end. Mathematically, you can pull this off like this. Acceleration is change of velocity over time interval. You have final velocity minus initial velocity. So you have an acceleration of 2 meters per second squared is equal to a final velocity, what you're looking for. What was your initial velocity? 0, because you're at rest. Started from rest over 6 seconds. So your final velocity is 12 meters per second. Good with that? All right. All right, everybody get out your speedometers. Show me speeding up with a constant acceleration. What does constant speeding up with a constant acceleration look like? Okay, could look like this. Could look like this. So long as your speedometer is moving at a constant rate. Good with that? Okay. Show me now speeding up with an increasing acceleration. Speeding up with an increasing acceleration look like? Okay, the rate at which you're speeding up is increasing. Now, once this next one, I want you to think before you act. Show me, not yet, just think, how would you show me speeding up with a decreasing acceleration? Go ahead and show your neighbor. Decrease, speeding up with a decrease in acceleration. Okay. So this has some tendencies to like break some paradigms. This is not speeding up. Okay. Your speedometer can't do this. Like that's not a thing. Okay. So you're speeding up with a decrease in acceleration, meaning that your acceleration is first large and then slows down. Okay. This is actually how your car works. When you punch it, it's like you can speed up from 0 to 20 real fast, but as you get faster and faster, it's harder and harder to get faster and faster. You are speeding up the entire time, just the rate at which you are speeding up is slowing down. You're speeding up the entire time, just your acceleration is decreasing because you're not speeding up as quickly at the end as you were at the beginning. Okay, do you see the difference between velocity, speed, and acceleration? Okay, so sometimes that's hard to differentiate between those two. Okay. Tell your neighbor.
Yeah. Wait, no. Yeah, more as soon as he's accelerating, it's C. It's starting to rest. Constant acceleration. Yes, so by the end of the first second, he'll have increased his velocity by. Oh, yeah, it starts to rest. Yeah. So it'd be B. No,
Correct answer is? Correct answer is B. By the end of that first second, you start at rest and go 1 Mississippi. By the time you reach the I in Ippy, you're at 5 meters a second. All right, with that, 1 Mississippi. Okay. The next question is the same scenario, just a follow-up. Talk to your neighbor.
It's like it's seconds square. So if you want in 1 second, it'll be 5. No, it would be these. It's like because this one start because it's a positive unless they give you it's one thing if one starts at 0, he will end as 5 meters, so it'd be impossible for it to be 5 meters. But the speed is 5 meters. Yeah, but so you like at the end, so he hasn't reached 5 meters. Yeah, just see or whatever they're doing is actually. It is also
Correct answer is? Correct answer is C. Okay. In order to go 5 meters, you would have to be traveling at 5 meters a second for the entire 1 Mississippi. Okay. Your speed, your velocity would have to be 5 meters a second for that entire second in order for you to travel 5 meters. However, it wasn't going 5 meters a second. It reached 5 meters a second at the end of Ippy. Okay. It started at rest, 1 Mississippi. Okay. So it traveled less than 5 meters. Good with that? So we have talked about position versus time graphs and how the slope of a position versus time graph gives us velocity. We've talked about velocity versus time graphs, and we talked about, I coached you, make up values. And then tell a story, what's going on with the velocity versus time graph. But I've never had you look at the slope of a velocity versus time graph. So if we were looking at the slope of a velocity versus time graph, what's on the y-axis for rise over run? Velocity. So change, oops. So if I'm picking 2 points, y2 minus y1, it would be final velocity minus initial velocity. x2 over x1, or x2 minus x1, would be final clock reading minus initial clock reading. So you have change in velocity over time interval. And that, my friends, is equal to acceleration. The slope of a velocity versus time graph gives you acceleration. Okay. Cool with that. So this is a little foreshadowing for when you take calculus. Slope is the same thing as derivative. So when you take the derivative of velocity versus time graph, it gives you acceleration. Okay. If you're not in calculus, tuck that back there when you get to it. Okay. Thumbs up when you have a guess. Tell your neighbor and tell them why.
Oh wait, no. Yes, we just do. Yes. I thought you were saying that. We're doing.
Correct answer is? Correct answer is C. How would you describe how you're moving? Constant velocity. So if you have a constant velocity, how much is your velocity changing? It isn't. You have zero acceleration. And what is the slope of this line? 0. So the value of acceleration is 0. Okay. Next question. Talk to your neighbor.
It's going down at a constant rate, like velocity graph. Then you have already the acceleration like I'm saying.
Correct answer is? A. Correct answer is A. How would you be moving to make this graph? Slowing down, going in the positive direction. Okay. The slope, how would you describe the slope? Positive or negative? Negative. Is it constant or is it changing? Constant. You have a constant negative slope. You have a constant negative value of acceleration. All right with that? Okay. Here's a little insight. In this class, acceleration versus time graphs will always be horizontal lines. We're going to assume that if velocity is changing, it's going to be changing at a constant rate. So accelerations are going to either be positive, negative, or 0. But they're always going to be horizontal. Okay, good with that? Okay, there are two answers that are like, but one's better than the other. Have a conversation. Correct answer is B. Okay, motorcycle has a steeper slope than the truck. Once it reaches that 50 miles an hour, yeah, go to that. Talk to your neighbor. Correct answer is A. Like it. She slows down in less time than she speeds up. So you have a steeper slope here, shallower here. Okay, this next question is the exact same scenario. This is a different question. Tell your neighbor. Correct answer is I like C a lot. Steep negative corresponds to a high negative value. Not as steep positive corresponds to a not as high value, but in the positive. Good with that? Last question. Motion. Tell your neighbor. Tell them why. Correct answer is C. Why? They're parallel lines. Same slope. Good. Okay, we got a reading or a pre-quiz for tomorrow. On Canvas.